This is a video on arctangent substitution. The question states, find the integral of dx over 1 plus x squared to the 3/2 power. So we look at this and it's messy, and it would be much nicer if this 1 plus x squared was just a single square instead of a sum of squares. And the key to making this work is the trigonometry identity. 1 plus the tangent squared of x is equal to the secant squared of x, because that takes a 1 plus a square and turns it into a single square. So I let x equal tangent of theta so that it'll all work out. So if x is tangent of theta and I take a derivative, I get dx equals the derivative of the tangent is secant squared of theta d theta. Now I have to deal with this 1 plus x squared to the 3/2. So I take 1 plus x squared to the 3/2. X is equal to the tangent of theta. So I get 1 plus the tangent squared of theta to the 3/2. But I know 1 plus the tangent squared of theta is the secant squared of theta. So I can write that as a secant squared of theta to the 3/2. But if I have a square to the 3/2, that's the same as the square root of the square cubed. So the secant squared of theta to the 3/2 is just a secant cubed of theta. And now it's much prettier and I can work with it. So now let's substitute it in. So we had an integral. Remember the dx was secant squared of theta d theta. And the over 1 plus x squared to the 3/2 was secant cubed of theta. So I have the integral of the secant squared of theta over the secant cubed of theta d theta. And I simplify that, and that's just the integral of 1 over the secant of theta d theta. But 1 over the secant of theta is very nice, because remember the secant of theta is 1 over the cosine of theta. So 1 over that is just the cosine of theta. And the integral of the cosine of theta d theta is very easy. That's just the sine of theta plus c. I'm not done yet because I have theta, and my original question was about x. So now I have to figure out what theta is in terms of x, or at least the sine of theta. And the way I do that is I draw a triangle. So here's our theta. Here's a right triangle. We know that the tangent of theta is x over 1, and the tangent is the opposite over the adjacent. So that means I put the opposite as x, the adjacent is 1. I can use the Pythagorean theorem and say that the hypotenuse is the square root of 1 squared plus x squared, or just the square root of 1 plus x squared. Now I want the sine of theta. The sine of theta is the opposite over the hypotenuse. So we can just plug in, and we can say that the sine of theta is x over the square root of 1 plus x squared. And then I have my integral of dx over 1 plus x squared to the 3/2 is equal to x over the square root of 1 plus x squared plus c. And I'm done with the problem.